Problem 1 from 2001 might be the most tedious problem I've run into in doing all these. What you have is you have a thundercloud. It's thought of as a positive charge of positive 30 coulombs 3 kilometers above the ground. And then we have a negative 30 coulombs that's at a distance of 2 kilometers above the ground, and then that induces the opposite charges on the ground. This is just a very tedious problem, which is doing the same thing over and over again. The calculation takes way too long on most of it. I would probably set up A, B, C, D, and E, and then move on, come back to it if you have time. Because again, the calculation isn't worth too many points, and it's very time consuming. First thing we're trying to do, determine the direction and magnitude of the electric field at point 1. Point 1 is at the ground level. We want to figure out what is the electric field from each one of those charges. So we're going to sum up the electric field from each one. Just got to be careful of your distances and watching the minus signs here. Each one of these has a K constant out in front. Negative 30 at 2,000 meters, positive 30 at 3,000 kilometers, negative 30 at 3,000 kilometers, positive 30 at 2,000 kilometers. You go through, you just do that math, you get 75,000 newtons per coulomb, and it's directed upward. You got an overall positive answer. Just a side note on this problem, my knee-jerk reaction was to try to use Gauss's law on this. But remember, even though the Q enclosed, if you circled P1 with a Gaussian surface, would be 0, the electric flux is not 0. So you still have electric field lines that are coming into that thing. So we don't actually want to do that. Okay, you can't use Gauss's law on that problem. That was my initial knee-jerk reaction. Okay, so that's how we figure out the electric field at point 1. At point 2, we have to have less electric field because we are further away from the charges. Point 2 has moved along the x-axis a little bit. That's increased the radius for each one of the charges. By increasing the radius and remembering that the electric field is 1 over r squared, each one of those electric fields is going to be reduced. Okay? Hopefully that makes sense. Letting the zero of potential be at infinity, determine the potential at these points, at P1 and then again at P2. All right? So here I'm summing them all up again because I don't know necessarily what they are. What I actually find by summing them all up, and I'm doing K, Q over R for each one, we get an electric potential of 0. Okay? So I'm confirming that the electric potential is 0 at point 1. I wasn't necessarily sure about that. This is me doing the direct calculation. And then by symmetry, the electric field at point 2 also, the electric potential at point 2 also has to be 0. You can think of it either in terms of equipotential lines or because of the symmetry. Hopefully this is straightforward for the first 2 parts. I'll pause, let you guys look at this. First 3 parts, A, B, and C. Okay, dramatic pause. Move the board over. Okay, determine the electric potential at 1 kilometer above point P. So the only thing that's changed, I got K outside, negative 30, 30, 30, and negative 30 again. But now the distances have changed. So watch your distances. We're 1 kilometer above point 1. So that's going to change these R values down here in the denominator. Please be careful of that. Straightforward calculation, we get negative 1.12 times 10 to the 8th volts. This is the most obnoxious part on the whole problem. Let me see how many points it's actually worth. Okay. The last part of this problem is worth 2 points, and it is the most involved. We need to figure out the electric potential energy for this full arrangement of charges. That means the electric potential energy between each charge. We remind ourselves that the electric potential energy, U, is going to be equal to the sum from the charge multiplied by the voltage, or the individual charges divided by the radius between them. So you're going to have 6 freaking terms here, okay? The 30 with the negative 30, the 30 with the positive 30, and then the 30 with the negative 30, watching each one of those R values, then the 30 with the negative 30, negative 30 with negative 30, and then we need that bottom term, the 30 with the minus 30. Guys, that's just way too much work. Just being honest with you, it's worth 2 points. You got 1 point for just setting up the correct equation. And they are being jerks on this. If you did not include the sum, they didn't actually give you the point. We're going to talk more about that later as we talk about what are some things that you need to be looking for. Okay? So the math here only gives you 1 point. You can work on that all you want. I would come back to it later. Again, shotgun blast approach to these problems. I'm not going to spend too much time solving them because I could be getting my points elsewhere. This is a very, very tedious problem. Just understand the theory and don't spend too much time worrying about the tedium.